South of Honshu Island in Japan, there exists an area of the Pacific that Japanese fishermen call Mano-umi, which can be translated as the Devil's Sea or the Cursed Sea. It corresponds approximately to an area between Japan, Guam Island, and the north of the Philippines, and has accumulated a reputation for nautical misfortunes that rivals that of the Bermuda Triangle. Between 1952 and 1954, the Japanese government officially recognized the disappearance of at least 5 fishing vessels in that area, with a total of more than 100 crew members missing. The response was unusual. The Japanese government sent a research vessel, the Kaiomaru No. 5, with a team of scientists to study the area. The Kaiomaru also disappeared in September of 1953, with 31 people on board. The subsequent investigation identified that the zone sits on a region of intense underwater volcanic activity, with several active submarine volcanoes and hydrothermal vents that can create anomalous currents, whirlpools, and sudden variations in the water structure. Furthermore, Pacific meteorological routes create storm conditions in that area that can go from calm to violence in a few hours. The scientific explanation is plausible and sufficient. But what is unsettling is the scale. These are not isolated accidents that can be attributed to occasional bad luck. It is a statistical accumulation of tragedies in a specific geographic area that suggests something systematically dangerous that we still do not fully understand. In all Spanish and Mexican nautical maps from the 16th century until well into the 20th century, there appeared marked a small island called Bermeja, about 110 kilometers north of the Yucatan Peninsula in the Gulf of Mexico. Multiple cartographers recorded it in different eras. Different navigators reported having seen it. It appeared in the 16th century Portolan charts of cosmographer Alonso de Santa Cruz, who was royal cosmographer to Charles I of Spain. And then in 1997, when the Mexican government commissioned a cartographic review of its territorial waters in the Gulf of Mexico in the context of negotiations on maritime limits with the United States, the island was simply not there. A subsequent oceanographic expedition searched in the coordinates where Bermeja was supposed to be. It did not find even a shallow shoal that could be the submerged vestige of the island. The water where Bermeja should be is deep, as if no rocky platform had ever existed in that location. The most likely explanation, from a geological point of view, is that Bermeja existed, but was a small volcanic island that was eroded and slashed or submerged by the rise in sea level since the 16th century. The Gulf of Mexico has zones of active subsidence where the seafloor descends slowly. None of that is confirmed. What is verifiable is that the disappearance of Bermeja was geopolitically convenient for the United States, because its existence would have considerably extended the territorial waters of Mexico in the Gulf. That is not evidence of anything, but it is the type of coincidence that feeds theories and that geology alone does not end up quieting. If the abyssal zone already seems the limit of the uninhabitable, the Hadal zone is what lies beyond that limit. The Hadal zone is not a continuous region of the ocean. It is a series of specific depressions, the oceanic trenches, cracks in the Earth's crust where tectonic plates dive under others in the process of subduction. They are discontinuous, deep, narrow, and in some cases completely isolated from each other, like inverted islands at the bottom of the ocean. The Mariana Trench, the Tonga, the Kermadec, the Puerto Rico. The pressures there exceed 1,000 atmospheres at the deepest points. The temperatures are near freezing point but without reaching it thanks to the salt. Darkness is absolute and permanent. No sunlight reaches. Practically no organic matter particles of the type that feed surface ecosystems reach. And yet, when the submersible explorer Deep Sea Challenger, piloted by James Cameron in 2012, descended to the 11 kilometers of depth of the Challenger Deep in the Mariana Trench, the cameras captured living organisms, amphipods, crustaceans similar to shrimp, so abundant they literally covered the floor of the trench in some areas. Sea cucumbers, polychaetes, foraminifera of gigantic dimensions with shells of up to 10 centimeters, incomprehensibly large for unicellular organisms. There is life in the most inhospitable place that exists on Earth, which means that the limits of the habitable that we establish with our biology as a reference are simply that, our limits, not those of life. The deepest known point of the planet is called Challenger Deep. It is in the Mariana Trench in the western Pacific and reaches 11,000 meters deep. By the time this video ends, that number may have been slightly revised upward or downward. Seismic measurements and ultrasonic soundings continued to be updated until very few years ago. The first person to physically reach the bottom of the Challenger Deep was Swiss oceanographer Jacques Piccard, together with United States Navy Lieutenant Don Walsh in January of 1960 aboard the bathyscaphe Trieste. They descended for 4.5 hours. When they reached the bottom through the small portholes of the Trieste, Piccard saw something that completely surprised him. A flounder, a flatfish, swimming serenely through the deepest place on the planet, as if it were any summer afternoon in the Mediterranean. That sighting was discussed for decades. Marine biologists argued that no vertebrate could survive those pressures. Subsequent studies suggested that the animal Piccard saw could have been an elongated sea cucumber, but the debate about the limits of vertebrate life in the Hadal Zone remains open. What is known is that the Mariana Trench is, in addition to an ecosystem, a sedimentary archive. The sediments at the bottom of the trench are an accumulation of millions of years of organic material that has been falling from the surface. In those sediments, there are microorganisms that feed on that matter, and through their metabolisms, they process carbon on a scale that scientists are only just beginning to quantify. The Mariana Trench is not just the deepest point of the planet, it is part of the global carbon cycle. In May of 2019, the NOAA research vessel Okeanos Explorer was performing routine mapping operations in the Gulf of Mexico when its multi-beam sonar detected an anomaly on the bottom at about 1,800 meters deep. They sent the ROV. What the cameras transmitted live was the interior of a completely unknown ship. There was no record of a shipwreck in that area. There was no historical file of a nautical accident that could correspond to its location. The ship rested on the bottom with the keel down, partially buried in the sediment, covered in marine life, as if it had been there for decades. The only visible characters on the structure were the number 2109, whose reference nobody could identify. The visual analysis from the ROV suggested 19th century construction, probably between 1850 and 1880, based on the type of copper used in the hull. Charred wood in some sectors of the ship indicated that it was possibly on fire when it sank. A fire on board in the middle of the sea in the 19th century that nobody survived to tell about, or that the survivors never reported with sufficient precision for a record to remain. The Gulf of Mexico is one of the most traveled seas on the planet since the 16th century, first by Spanish galleons transporting silver from the Viceroyalty of New Spain, and later by Anglo-Saxon and American trade. Its depths guard hundreds of shipwrecks, most uncatalogued. Every time NOAA lowers an ROV to the bottom, it finds something it did not expect. At the bottom of the Gulf of Mexico, at about 1,000 meters deep, there exists a lake within the ocean. It is not a metaphor, a distinct body of water with its own shore and surface, separated from the surrounding ocean by its density. Its salt concentration is 5 times higher than normal seawater, which makes the ocean water float over it without mixing. They call it the Jacuzzi of Despair, partially because of its slightly higher temperature than the environment, and above all because of what it does to everything that falls inside. It is saturated with methane and hydrogen sulfide, and it kills any organism that penetrates it beyond its edges. On its shore, there is a small graveyard of crustaceans that got too close. On its margins, where the hypersaline and toxic mixes with normal oceanic water, communities of chemosynthetic bacteria and extremophiles thrive. Astrobiologists study it carefully because its conditions are reminiscent of those that could exist in the subterranean oceans of the icy moons of the outer solar system. On March 1, 1999, NOAA hydrophones recorded a 15-second sound in the equatorial Pacific, so powerful that it was captured simultaneously at multiple stations separated by thousands of kilometers. They called it Julia. NOAA's official hypothesis is that it was produced by an iceberg running aground or sliding over the Antarctic seafloor, whose low-frequency sounds travel thousands of kilometers through the ocean's SOFAR channel. It is a technically solid explanation, but the sound of an iceberg scraping the bottom is irregular and chaotic. Julia has a more complex waveform, with amplitude variations that some researchers have described as almost modulated, almost as if something were deliberately shaping that sound in the darkness. Between Sri Lanka and the Indian island of Pamban stretches a chain of outcrops and sandbanks of about 50 kilometers. The Ramayana describes it as the causeway that the army of the god Rama built in 5 days to rescue his wife Sita. Geologists confirm that the rocks are of natural origin, without evidence of human construction. The mystery arises in the dating data. The rocks that form the structure are between 100,000 and 300,000 years old, but the sand sediments on which they rest are only between 2,500 and 7,000 years old. The rocks are much older than the bed that supports them, which implies they were transported there by some process, natural or not. Until the 15th century, the sea level was low enough for the structure to be above water and transitable. If someone walked across it, that memory was recorded in the stories that centuries later became the Ramayana.